The short-run cost and expenditure curves in graph 13.1 were all derived assuming that the capital level is fixed at 100 in the short run. Of course, we could have fixed the capital level at any other quantity and gotten different short-run curves. There's therefore a set of short-run curves for each level of capital that the firm might be taking as fixed in the short run. And in this graph here, we'll illustrate how those relate to one another. We'll start with our isoquant and isocost graph, where we have labor on the horizontal axis and capital on the vertical. And we begin with the particular isoquant that corresponds to producing 200 units of output. We'll further assume that the rental rate for capital is 10 and the wage rate is 20. The least cost way of producing 200 units of output is then given by the tangency of the appropriate isocost that has a slope of -2 with the isoquant for producing 200 units of output. This occurs at production plan A, where we're using 50 hours of labor and 100 units of capital to produce 200 units of output. We'll assume a production technology such that if you wanted to switch to producing only 100 units of output, the least cost way of doing so would be to use 25 hours of labor and 50 units of capital, as illustrated by the production plan B. If you start at production plan A, however, you can't switch to B immediately, because capital is fixed in the short run, and you can't just change it from 100 to 50 and not pay for the other 50. Thus, in the short run, you're restricted to a slice that holds capital fixed at 100, and if you want to switch to producing only 100 units of output on the magenta isoquant, the only choice you have is to pick production plan D. If you wanted to produce 300 units of output, the least cost way of doing so in the long run is to switch to production plan C, where you use 75 units of labor and 150 units of capital to produce the 300 units of output. But again, if you start out at production plan A, you can't move to C immediately, because capital is fixed in the short run. In the short run, you therefore have to operate on the slice that holds capital fixed, and the only way you can reach the isoquant for 300 units of output is to choose the production plan E. In panel B, we illustrate the blue total expenditure curve for a fixed capital level of 100, as well as the green long-run cost curve, which assumes that you can vary labor and capital as much as you'd like. We begin with the output level 200, which in the long run we'll want to produce by using production plan A. At that production plan, we hire 50 hours of workers for $20 per hour and 100 units of capital for $10 per hour, for a total long-run cost of $2,000. In the short run, if we are fixed to using 100 units of capital, we'll also choose the production plan A. Therefore, our short-run cost for labor is exactly the same as our long-run cost for labor, and our short-run fixed expense on capital is exactly equal to the amount we spend on capital in the long run. For this reason, the total expenditure, given that we're fixed to using 100 units of capital, is equal to the long-run cost of producing 200 units of output. If we only want to produce 100 units of output, the long-run cost minimizing production plan is production plan B, which costs $1,000. If, on the other hand, we'd like to produce 300 units of output, the long-run cost minimizing production plan is production plan C, which costs $3,000. We therefore get a long-run cost curve where we assume that we can vary both capital and labor as is a straight line. This is a direct result of the fact that we've assumed constant returns to scale in the underlying production technology in panel A. Whenever we double the inputs, we exactly double the outputs. It therefore never gets easier and easier to produce, and it never gets harder and harder to produce, which means that each additional unit we produce will cost the same as the last unit that we produced, creating a linear, upward-sloping long-run cost curve. The more we want to deviate from the production level 200 in the short run, the more of a disadvantage it'll be to have a fixed level of capital of 100, which is just the right amount of capital to use to produce 200 units of output. For instance, if we want to produce 100 units of output and we're fixed to using 100 units of capital, we have to do so using production plan D. D lies on a higher ISO cost than B in panel A, and it therefore costs more, or in the short run language, the expense associated with the production plan D is higher than the expense associated with production plan B. The total expense is therefore higher in the short run than the cost is in the long run when we want to produce 100 units and we're fixed to using 100 units of capital. The same is true if we want to produce 300 units of output and we're fixed to 100 units of capital. We now can only do so using production plan E, which costs more than production plan C. Therefore, the expense associated with the production plan E is higher than the long-run cost of producing 300 units of output using production plan C. Dividing the dollar amounts on the vertical axis by the output levels on the horizontal axis for the points B', A', and C' in panel B, we can calculate the average cost in the long run of producing these different output levels. Connecting these, we get the long-run average cost curve, which is flat at $10. This arises from the fact that we've assumed a constant returns to scale production technology, which in turn gave us a linear upward-sloping long-run cost curve. The average cost doesn't change because it never gets any harder or any easier to produce, so long as we can vary both labor and capital, which we can do in the long run. For reasons that are apparent in panel B, the short-run average expenditure curve when capital is fixed to 100 will then lie above the long-run average cost curve for all output levels except the output level 200, at which the fixed capital of 100 is the cost-minimizing level of capital to use. Had we instead fixed capital to 50 in the short run, we would have fixed it to the level that we would be choosing in the long run if our intent was to produce 100 units of output. Thus, the average expenditure curve for a fixed capital level of 50 will also lie above the long-run average cost curve, but will be tangent at 100 units of output instead. This is because when we want to produce 100 units of output, the least cost way of doing so is using production plan B, which involves 50 units of capital. So if we're fixed to using 50 units of capital, we are in fact using the least cost way of producing 100 units of output in the long run. The short-run total expenditure curve for a fixed capital level of 50 would then be tangent at point B' in panel B, which is ultimately why the average expenditure curve for 50 units of capital is tangent at point B' in panel C. And had we fixed the capital level to 150 in the short run, we would have fixed it to the level we would choose in the long run if we wanted to produce 300 units of output. Thus, the average expenditure curve corresponding to a fixed level of capital of 150 lies above the long-run average cost curve everywhere except for 300 units of output.